Right, let's get started with our polynomial factorization unit test. And for the first question, we have factor completely this thing. Okay, so I can write 100 as 10 square and 81 as 9 squared. We know that 9 square is 81. And we can take out p to the power 4 outside so that if we square that, power gets multiplied. This thing is written like this. Then we can use the formula a square minus b square equals a plus b bracket multiplied by a minus b. So here a is 9p to the power 4. So 9p to the 9p to the power 4 plus 10 times 9p to the power 4 negative 10. This would be our answer. So 9p to the power 4 plus 10, and that thing is multiplied with 9p to the power 4 minus 10. So this is our factor. Find the missing factor a that makes the inequality true. Well, we can find a by dividing 8x cubed with negative 2x. So this gets cancelled out with x squared, 2 with 4. So we're left with negative 4x squared. So this is the value of a, negative 4x squared. Okay, negative 4x squared. Let's see. All right, which of the equations are true identities? Okay, so which means the left hand side must be equal to the right hand side. Let's see, let's expand right hand side and see whether that equals the left hand side or not for the first one. So I'm going to multiply everything with m. So m plus m squared plus m cubed. Now I am going to multiply everything with 1. So I remove this. So m plus m squared plus m cubed. Now we will have negative 1, negative m squared. So positive m squared, negative m squared gets cancelled out. Positive and negative m comes cancelled out. So m cubed, negative 1. A is an identity. What about b? Let's expand this using the formula a plus b whole squared. So we have n squared plus 2 into n into 3, 6n plus 9. What do we have? Also plus 2n. Okay, but this is not true. Where is the n square? So only a is our answer. All right, we have to factor completely this equation. And because it has x to the power 5, we want to plug in this to Desmos. So x to the power 5, then we have negative x to the power 4. X to the power 5, negative x to the power 4 plus 3x plus 3x. No, not this one. X negative 3. So x to the power 5, negative x to the power 4, positive 3x minus 3. So what do we get? We get 1. We get 1. X equals 1 as the only factor, the only root. So if x equals to 1 is the factor, is the root, then x minus 1 must be the factor. If it is the case, then we have to do long division to find the other factor, because there's only one root, x equals to 1, so x minus 1. So what do? We write x to the power 4. So x to the power 4 plus 1 is 5, negative x to the power 4. If we cancel this, this becomes positive, this gets cancelled, this also gets cancelled, we are left with positive 3x negative 3. We can write plus 3, so that gives us 3x negative 3 and a remainder of 0. So x minus 1 and x to the power 4 plus 3 gives us the same graph, as you can see, the same graph. So our factorization is correct. So what you have to do is write this here. The rectangle below has an area of okay, of 15 k to the power 4 plus 35k square k cube plus 20k square. The width of the rectangle is equal to the greatest common monomial factor of these. What is the length and width of the triangle of the rectangle? Okay, so we want to first find the width, which is the greatest common monomial factor. We can factor out 5 from each of them. Yeah, we can't do with 10, so 5. We are left with 3, 7, and 4 here. 5, 7 is 35. Okay, 5 4 is 20, 5 is 15. And we can also factor out k square as well. So 5k square will be the monomial factor. So what are we left with? 3k square plus 7k plus 4. So let's check whether our factorization is correct or not by multiplying these and seeing whether this we get the original equation or not. So 5 3 is 15, k to the power 4 plus 7 5 is 35, k cubed plus 5 4 is 20, k square. Yep, our factorization is indeed correct. So this is the width, 5k square. And regarding the length, we know that area equals width times length. So this is being multiplied with this thing. So this must be our length, which is 3k squared plus 7k. And we have a plus 4. Every year, Francisca earns a salary that is 2% higher than her previous year's salary. So if the first year's salary is X, the next is 2% higher, so 102% of X. In her first 5 years at his job, she earned a total, okay, the sum of all terms, the sum of the first 5 terms, 1 to 5, is this thing. What was Frances' salary in her first year job? Round your final answer to the nearest thousand. Well, this is a geometric progression, and we know that the common ratio is 102%, which is 1.2. 102%, which is divided by 100. 1.02, my bad. 1.02, because 2% higher than her previous year's salary. So the formula for the first 5 terms is Sn equals a times 1 minus r to the power n over 1 minus r. So first is the thing that we don't know, we let that be x. We know the sum, which is 187,345. Let's write it here. 187,345. 187,345. 187,345. This is equal to, now the x is the unknown that we're trying to find, multiplied by 1 minus r. So this thing multiplied with 1 minus r. Now the common ratio is 1.02. 1.02 to the power n. So we want the n is the number of years, which is 5. So that is raised to the power 5. 5. And finally, we divide 1 minus r. So what do you have? This is the answer. Now we have to find x, which is here. Okay, so this thing is our x, and round the answer to the nearest thousand decimal. So we know that this is ones, tens, 100,000, 3 decimal places. So 914. Let's see. All right, that's great. Factor the polynomial by its greatest common monomial factor. I can take out 3, not 6, not 9, because 27 is not divisible by 6. It's divisible by 3, so 9. So I can take 3m out. So we have 3m squared negative 9. Let's see. 3 3s are 9. M cubed negative 9 3s are 27 m. 9 3s are 27 m. So 3m square 3m times 3m square negative 9. Factor the polynomial by its greatest common. We have done so. Oh, we can take out 9. My bad. So I can write 9m. So this will be just m squared negative 3. Oh, that's a silly mistake. Blunder. Yeah. M squared negative 3. Now it should be fine. Alright. We have to factor this completely. X to the power 4 plus 5x cubed. X to the power 4 plus 5x cubed plus 4x plus 20. X to the power 4 plus 5x cubed plus 4x plus 20. So we have these two roots. Yep. So what are they? Difficult. I have to factor completely. So what we can do is, we know one root. So this is the equation here that I've written. We know that we have a root at x equals to negative 5, which means x plus 5 is a factor. What do we get if I divide this thing with x plus 5? Divide by x plus 5. So x plus 5, we get this thing. But I need the equation. I also got a root here. Anyway, I have to do the dirty work. Long division. So x plus 5. X to the power 4 plus 5x cubed plus 4x plus 20. So x cubed, we have x to the power 4 plus 5x cubed. Subtract this. Cancel out 4x plus 20, so we're left with 4. 4x plus 5 is 20. We're left with x cubed plus 4. X cubed plus 4. And this thing's multiplied by x plus 5. Should be the same thing as this. It is indeed. X plus 5, x cubed plus 4. There we go. I needed not to do all of that. Anyway, 2p whole squared negative 5q whole squared. 2p plus 5q. The same thing. I'm using the formula a square minus b square. equals a plus b, a minus b, just like the similar one that we have done before. And finally, which of these equations are true identities? Well, let's see. If I multiply this thing with everything, so I get 6xy negative 9x squared. And now the time for negative 2y. So negative 4y squared positive 6xy. So 6y plus 6y don't cancel out, so it is not the case. A plus b, a minus b, a square minus b square, so b only. This is correct because we know the identity a square minus b square equals to a plus b, a minus b. Here is not correct because 6x plus 6x becomes 12x. We don't have that, the term 12xy. And here, this is a, this is b, and the square of them are correct. So only b. This is the end for our unit.